Hmm. See?
This meeting is being recorded.
Good evening, ma'am. This is Lakshmi Priyanka. Our project title is Edge Detection using Image Processing using Fuzzy Logic. Our team members are Varmal Prasanna Kumar and me, ma'am. Can I share it? Digital image processing is a subset of the electronic domain, ma'am, in which an image is converted to an array of small integers called pixels that represents a physical quantity such as scene radiance and stored in a digital memory before being processed by a computer or other digital hardware. In soft computing techniques, fuzzy logic is a useful mathematical method for dealing with knowledge ambiguity. Many valued logic is a type of fuzzy logic. When we go to the basic intro of our topic, the basic necessity of choosing this application is of the edge detection algorithm is used for a variety of tasks in image processing, including segmentation, registration, identification, and recognition. The majority of edge detection has a fixed result, such as edge thickness or some other parameters. In history, we can see about the edge detection, which has been one of the most popular research areas since the early days of computer vision. Through a number of algorithms have been published. The task of identifying significant local changes in a picture is basically the same that we have been detecting an image. In real-time problems domains where the chosen soft computing technique is useful for recognizing, representing and process images of their parts and features as fuzzy set is known as fuzzy image processing. In methodology, the most crucial steps in fuzzy image processing are represents and processing, which are determined by the fuzzy technique chosen and the problem to be solved. Image fuzzition membership value adjustments, and it is necessary of maximum 5 defuzzification images we can see in the output of the implementation part. This is the basic data set specification, and we have done total 10 literature review papers. These are the 10 literature review papers. We have done the
So these are the comparative study of the research review. Okay, these are the comparative research what we have done. And the next we have to go. This is the complete system design. So here we need to import the RGB image and convert to the grayscale. So that will be input to the fuzzy converter, which can convert crisp input to the fuzzy input. So that will be input to the fuzzy interface system. So in this, we have used Mamdani fuzzy interface system. So we need to specify some fuzzy inference system rules, and then we need to evaluate the fuzzy inference system. Then the output will image. Then we need to stop the process. So this is the entire procedure. Input image, we need to pre-processing. So the original image is converted to some grayscale image. Then, so based on some fuzzy logic rules are identified and fuzzification is done, then that will be input to the fuzzy interface system. Then defuzzification, then the output image. So here fuzzy set theory comes into the picture. So knowledge base. So detailed description of the modules. Here we have the input image. So import RGB image and convert to the grayscale. That is the first step. So the input image stored in the form of link from the browser. So here it converts to 3 by 4, 5 12 into 8 unit of arrays. So the 3 channels of third array dimensions represent the red, green and blue intensities of the image. So convert these into the grayscale so that we can work with the 2D array instead of 3D array to do so. So next we have the fuzzification process. Fuzzification is the process of decomposing a system input and output in one or more fuzzy sets. So here we need to convert the image into the double precision. So data evaluate fuzzy interface system function for evaluating the fuzzy interface system. Suppose only single precision and double precision data. Therefore, converting array to a double array using IM to double E to the function. So we can show you everything in implementation now. So next, GX and GY are the single gradient filters. So to obtain a matrix containing x-axis gradient of phi, and we convert that GX will convert to the functions. So these are the two functions which are used for, and then fuzzy interface system, the third one. So in this we create a fuzzy interface system. So edges specify the image gradient x, y, and input of the edges. Specify a non-zero Gaussian membership functions, and each input in the gradient value of pixel is 0. Then it belongs to the non-membership function with the degree of 1. So here we have used triangular membership function. So specify the fuzzy rules. So add rules to make a pixel white. It belongs to the uniform region and black. Otherwise, a pixel is uniform region. Then the image gradient is 0 in both directions. If either directions is non-zero gradient, then the pixel is on edge. So at last we have evaluate the fuzzy inference systems. So evaluate the output of the edge detector for each of pixels. I am using corresponding row stacks and I have an input. So these are the software requirement specifications. So these are the code. So this is the screenshots with explanation. So this is the actual original input. So initially the input which is converted to the grayscale. This is the grayscale image. What we have, what output of the first image. This is the figure 2 image with the image gradient along the x-axis. This is the image gradient along y-axis. So this is the membership functions quality ix, iy, and iout. So graph after plotting the membership functions of the inputs and outputs of the edges. So these are some mathematical calculations we have done with the MATLAB. So I have an original grayscale image after entering into the fuzzy inference system. Next is the original grayscale after plotting. So this is the final output, edge detection using fuzzy logic. So these are the references we have done. So I will show you the implementation now. Hello, Prasanna. Hello. Hello. No, make me a presenter.
Okay.
Hello. Okay. Prasanna, your screen is visible. So ma'am, so this is the code actually. So we have used Mamdani fuzzy interface system, fuzzy inference system. So here the procedure, everything we have discussed in the entire modules now. So here we are adding membership functions. So Gaussian membership functions. And here for HFIS we are adding triangular membership functions. These are the weights. So we are plotting. So if I run this code,
Specifying FIS rules also, ma'am.
file. Run it again. So these are the mathematical calculations we have done. It was going to processing. So these are the descriptions. So X, IY and I out. So these are the 6 images what I have shown in the PDF, ma'am. So this is the first image, input grayscale image, which, so this is the IX layout. This is the IY. So this is the membership functions, degree of membership functions graphs. This is the original grayscale image map. This is the original grayscale image map. And this is the edge detection using Fuzzy. This is the final output. So we have got absolutely. So 70% of the accuracy we have received. Thank you, ma'am.